Yeah, welcome back to Gallant Digital Academy. And just as promised, we are going to continue our series on frictional force, on friction. We're treating the calculation aspect. Basically, what we're doing today is our questions, right? We'll be treating a total of 10 questions, starting from the basics. That is the simple questions I expect every one of you to know as long as you've been following me all through. I get in? Alright, so we'll ascend gradually. Alright, the first question. Which of the following surfaces typically has the highest friction coefficient or the coefficient of friction? We have here smooth metal, we have rough metal, we have polished, and we have lubricated. All right, you should know that this, and this are more or less the same thing. I get in because the frictional force experienced by a smooth metal, let's say something like this, maybe a ball bearing, right? Something like this, and a smooth and a surface, right? The friction between them will be less, right? A polished surface is one that is also smooth. Forget English. It's one that is also smooth. I get it, which was once rough, but due to some process is now smooth. Exactly. Lubricated must not is not necessarily smooth. I get it, but due to the presence of lubricant, I get it, the frictional force that exists between these surfaces has been reduced. Exactly. So what will be the correct answer here? What do you think will be the correct answer? Polished glass. Correct. So for this, C is our correct answer. Is that clear? All right. I want you to do me a favor before answering any question here. Ensure that um, you pause the video. Are you getting right? Pause the video, attempt it first, then confirm if you get it right or wrong. I guess that's the best way to learn. Do you get that? All right. So question 2: what is the force that opposes the relative motion? Right? What's the force that opposes the relative motion of objects in contact? That opposes. In short, this is more or less like the definition of what? Is it gravity? No. Friction? We don't know yet. Let's see. Tension? No. Inertia? No. I get it. All right. Now, gravity is the force that makes us grounded. I get it. The pulling force is a pulling force, right, to the center of mass, right? Frictional force. Let me skip that. Tension is like exists in rope. I get it. Exists in any any substance, any material that is experiencing a force, right? So tension can be found in any material experiencing a what? A force, right? So inertia is the ability, is the state or the ability of an object to continue to remain in at rest, to continue to remain at what? At rest. So in this part now, frictional friction is what? Correct, because of the word oppose, relative motion, object in contact. All right. Question 3. The coefficient of friction is defined as what? What I say the coefficient of friction is? This is the sign of coefficient of friction. What I say it is? Okay, first of all, frictional force is directly proportional to what? Normal reaction, just like what I said in the previous video, right? So, coefficient of friction being the proportionality constant will now be F equal to this N, right? So, making coefficient of friction, show you the formula, is equal to what? F over N. Alright, so this is simply the formula. So what does this tell you? Frictional force to normal force. Frictional force to normal force. What does that look like here? Option C. Option C is correct here. Alright, so the first question, which factor does not affect the magnitude of friction between two surfaces? Right? Which factor does not affect the magnitude of friction between two surfaces? A. Surface roughness. Does surface roughness actually affect friction? Can you think that through? Yes, it does. It does. It does. Right? Okay. What of normal reaction? Okay, I tell you that normal reaction is opposite but equal to the weight. So if it's equal to the weight, that means normal reaction will affect friction. In short, whenever you see a formula, it tells you a lot about what affects that quantity. Like now, friction is affected by both is affected by what normal reaction. So frictional force is affected by normal reaction. So this is part of what affects friction. What of temperature? Okay, now temperature affects. When I get to teach you about tension, you understand why temperature affects. Now, for instance, let's say a red oil, for instance, right? A red oil that placed in the fridge, right, and one that is on fire. The way both of them will be flowing, their flow rate will actually differ, right? You expect the one that is being heated, that has been heated, to flow at a faster rate. So lesser friction or lesser viscosity, though it's viscosity, but it's somewhat related to what? To friction. What color? Regardless of the color of the material in contact, friction exists, so it doesn't matter. So in this case, color is the correct answer. Or we are getting it. Alright, the next one, question 5. Now they said a wooden block of mass. So let's write out the parameter. Whenever you see a question like this in exam, write out your parameter first. That's the first thing to do. So our mass is equal to what? 1.6 kg, right? Rest on a horizontal surface. Alright, let's assume this is a horizontal surface, right? So we have a box. Alright, so we have a box on this part, right? So if the limited frictional force between the block and the surface is 8 Newton, so frictional force is 8 Newton. Calculate the coefficient of friction given that acceleration due to gravity is 10 meter per second, right? Alright, so coefficient of friction again is equal to what? Frictional force over what? Normal reaction. Okay, frictional force over what's the normal reaction? What I say normal reaction is, okay, normal reaction is what? mg. I hope that's clear, right? Okay, so we have our frictional force. We know what our m is, and we know what our g is. So that's simple now. So we have 8 divided by 1.6 times 10, right? So 8 divided by 1.6 times 10 is what? 16. 8 here 1, 8 here 2. So 1 divided by 2, which is what? 0.5. 0.5 what? What's the SI unit? No SI unit. I told you that, right? So our coefficient of friction is equal to 0.5 without any SI unit attached to it because it's dimensionless. Alright. Question 6. We're told to calculate the magnitude of the force required to move a 20 kg object. So mass is equal to 20 kg, right, along a horizontal surface if the coefficient of friction is 0.2. So coefficient of friction is 0.2, right? So automatically G is equal to 10 meter per second, right? Okay, calculate the magnitude of the force required to just move a 20 kg object along the horizontal surface if the coefficient of friction is this. So we're going to calculate the magnitude of force. Now, take note of this just. Because as we solve complicated questions, you will notice that we can have something like this. We can definitely have something like this, but just because they say just, it simply means that our F is also equal to what? FR, right? So I can now say this is equal to FR over mg. So this mg is also known as normal reaction. I've told you countless times. Okay, frictional force is what we're told to find, right? This is what? 0.2, and our mg is what? 20 times 10. So just cross multiply, as simple as that. So frictional force is equal to 0.2 times 20 times 10. So this and this, 10 times 0.2 is what? 2 times 20, 40. So 40 what? Will I leave like this? No, 40 Newton. Is that clear? Now to the next question, question 7. Now which type of friction is typically the smallest? which type of friction is typically the smallest? Can you think it through? Which type of friction is typically the smallest? If you've been following me all through, then you should know this. You should have an answer to this without me stressing myself. Now, static friction is the friction that exists between two surfaces in contact, right? When both surfaces are static, right? Kinetic friction, one of the surface or one of the objects in contact, right, is moving, right? Good. But what differentiates this and this, because both rolling friction and kinetic friction involve materials, involve objects which are what moving. I get it. So how can we differentiate this and this, right? And this too, right? This involve fluid, like gas, water, and the rest, right? Okay, now the area in contact here is greater when compared to this, which is lesser. This is also greater too. That is when comparing to this. I'm comparing to this, and I'm comparing to this, right? Okay, so what do you think the answer will be? Exactly, rolling friction. So here, rolling friction is what? Correct. Do you get it now? Rolling friction is what? Is correct here. Because look at this. Let me just give you an example. Right? There is very little surface in contact. Right? Unlike when we have something like a box. Right? So there is higher surface in contact. There is higher area in contact compared to just this little place. Is that clear? Okay, good. Next one, question 8. When does rolling friction occur? When does rolling friction occur? Okay, first they said when two surfaces are sliding past each other. Kind of correct. Okay, when an object is rolling over a surface. Okay, when a fluid is flowing past an object. Okay, when an object is at rest. This static friction. Let's start from here. Alright, so when a fluid is flowing past an object, so this can say, let's say fluid friction. When an object is rolling, so they've given you the answer alone. I get it. So this is rolling friction here. Okay, when two surfaces are sliding past each other, when two sliding what? Friction. Alright, so what do you think the answer will be here? B is correct. Good. Alright, question 9. A wooden block has a mass. Write out the parameter first. Is sliding on a rough surface with a coefficient of friction 0.3. If the horizontal force, that is F, is equal to 15 Newton, is applied to the block, what is the acceleration? You have to find the acceleration. Now, in this kind of scenario, we don't need this. Is that clear? We don't need this. All we have to do is use F equals what? ma. That is 15 is equal to what? 2 times acceleration divided by 2. Acceleration is equal to 7.5 meter per second squared. Notice the square instead of meter per second, right? So meter per second squared. Alright, now the last and final question. A car of mass 1000 kg is traveling at a constant speed of this. So we have v equal to, okay, constant speed, so u equal to 20 meter per second on a horizontal road. If the coefficient of rolling friction between the tires and the road is 0.3, what force is required to maintain this speed? What force is required to maintain this speed? Alright, let's first of all write our formula. Frictional force over what? N, right? Which is frictional force over this is what? Mg. Exactly. We know this. We know this. We are looking for this. We have this, and we have this. Right now, this is what useless. This quantity here is not useful, right? Except we're told to go for further calculations. Now, what this here, this is what we're going to do here. Make FR, so the formula becomes coefficient of friction times M times G. So coefficient of friction is 0.3 times 1000, right? Times our G being what? 10 meter per second, right? This and this will give what? 3. So 3 times 1000 will give what? 3000 Newton. All right. Thank you so much, Mavericks, for being here. Thank you so much for staying on to this part, right? I ought to give you home task, but I will skip that part, right? So in the next video, which will be our more or less like final video, right, I'll give home task which you have to submit to our email or in the comment section, right? So make suggestions on the next video we should make, make suggestion on the video we should make next, right? Do you enjoy the video? Comment, try to like, subscribe, right? Very important. Subscribe, like, and share. All right, thank you so much for staying with me up until this moment. Thank you so much. God bless you. Bye.